students, I hope all of you are doing good. Let's start today's chapter, relation and mapping. Relation. The concept relation necessarily refers to an association of two objects based on some property they possess. Thus, if A and B are two non-empty sets, then a relation from A to B is a rule which associates the element of set A with that of B. Let us consider some examples to illustrate the concept of relations. Number one, consider some countries and their capitals. Like New Delhi is the capital of India, Washington is the capital of USA, Islamabad is the capital of Pakistan, London is the capital of UK, and Tokyo is the capital of Japan. So in the above tabulation, the relation is the capital of, means New Delhi is the capital of India, right? 2, consider A is equals to 2, 4, 6, 8 and B is equals to 1, 2, 3, 4. Okay. Here the relation is double of, means 2 is double of 1, 4 is double of 2, 6 is double of 3 and 8 is double of 4, right? Now number 3, consider the two sets C and D. Okay. So here elements of C are 0, 1, 4, 9 and elements of D are 0, 1, 2, 3. So here the relation is square of 0 is the square of 0, 1 is square of 1, 4 is the square of 2, right? Ordered pairs. An ordered pair is a pair of objects selected in a specified or specific order. For example, in coordinate geometry, we select ordered pairs to represent different points. For example, the pair 0, 0 represents the center and pairs like 5, 2 or 4, 1 represent different points in the coordinate plane. Okay. Equality of ordered pairs. Two ordered pairs x and y and a, b are called equal only if x is equals to a and y is equals to b. Okay. Representation of a relation by ordered pairs. If two sets A and B are non-empty sets, then a relation from A to B is represented by listing the matching pairs. This way of representation of a relation is called a roster form. Okay. In roster method, the ordered pairs so selected have their first element from set A and second element from set B. Okay. So here for example, let A is equals to 1, 4, 9, 16, 25, 36 and 49 and B is equals to 1, 2, 3, 4, 5, 6, 7 and its relation R is what? Square of. So it is represented as follows, means square of 1 is 1, square of 2 is 4, then we have 16, 9 and 3, square of 3 is 9, okay. So this is the representation of a relation by ordered pairs. Now representation of a relation by arrow diagram. In this form, a relation is represented by drawing arrows from first components to second components of all ordered pairs that satisfy the given relation. For example, let A is equals to 1, 4, 9, 16, 25, 36 and 49 and B is equals to 1, 2, 3, 4, 5, 6, 7. Then the relation R is a square of, can be represented like this. Here it is given, okay. 1 is a square of 1, 4 is a square of 2, 9 is a square of 3, right? Next, domain and range of a relation. When A and B are two non-empty sets and R be a relation from A to B, then domain of R is equals to the set of all first components of all ordered pairs which belong to R, and range R the set of second components of all ordered pairs which belong to R. For example, let A is equals to 1, 4, 9, 16, 25, 36 and 49 and B 1, 2, 3, 4, 5, 6, 7 and the relation is square of. So we have R is equals to 1 is the square of 1, 4 is the square of 2, 9 square of 3, 16 is square of 4, okay. So here domain of R are what? 1, 4, 9, 16, 25, 36, 49 and range of R is 1, 2, 3, 4, 5, 6, 7. Is that clear? Next, mapping. If A and B are two non-empty sets, then a mapping from A to B is a rule which associates every element of A to a unique element of B. This unique element is called an image. This relation from A to B is a mapping if each element of A has a unique image in B. Condition for a relation to be a mapping. Number 1, when the relation is represented by an arrow diagram. If A and B are non-empty sets and there exists a relation R from A to B, then R is a mapping if A, every element of A is connected with some element of B. B, no element of A is connected with more than one element of B. Okay. For example, consider the following figures. Elements of A are 1, 2, 3 and elements of B 5, 6, 7, 8. So each element of A is connected with a unique element of B. It is a mapping. Okay. And next is small ABC and DEF. It is not a mapping as B is left out and the element is A is connected to two elements of B. That is A and then D, E and C, F. Okay. So B is left out here. Number 2. When the relation is represented by the roster form, if A and B are two non-empty sets and R be a relation from A to B, then R is a mapping. If A, every element of A appears as a first component of some pair in R, in other words, the domain of R is equals to A. And B, no two different ordered pairs in R have the same first component. Number 1. Let A is equals to 1, 2, 3, B is equals to 1, 2, 3, 4, 5 and 6. And relation from A to B, R is equals to, what is R? 1 and 4, 2 and 5, 3 and 6. Your domain of R, that is 1, 2, 3 and so ordered pairs in R have the same first elements. Hence it is a mapping. 2. Let A is equals to 1, 2, 3, B is equals to 1, 2, 3, 4 and the relation be a factor of, so R, 1 is a factor of 1, 2 is a factor of 2, 2 is a factor of 4, 3 is a factor of 3. So here the domain 1, 2, 2, 3 is equals to 1, 2, 3. But the two ordered pairs have the same elements. Hence, it is also not a mapping. Exercise 17.1. Draw arrow diagrams to represent the following relations. Okay. We'll make two circles 1, 2, 3, 4, 5, 6. Okay. 2 and 5. How 2 is related to 5? Okay, you will in this direction. Then 3 is related to 5. Okay. 1 is related to 6. Okay. And 1 is related to 4. Okay. So this is the diagram. Okay, students, now you will do practice of the remaining questions, right? Things to remember. Number 1, relation is an association between two objects due to some specific property in them. 2, an ordered pair is a pair of objects taken in a specific order. 3, a relation from A to B is represented in roster form and by arrow diagrams. 4, if R be a relation from A to B, then the domain of R is equals to set of all first components of R. The range of R is equals to set of all second components of R. 5, a relation R from A to B is a mapping if each element of A has a unique image in B. That is, number 1, domain of R is equals to A. 2, first component of different ordered pairs of R are not repeated. So here comes the end of this chapter, students. Now you will do practice of this chapter.